So procedural block in Verilog, and as you know, the procedure is means that step-by-step process. So this block is also same. There are a number of blocks like initial, always, and final. So let's see its proper definition. Is procedural blocks in Verilog describe sequential behavior. As I said earlier, a process is having a step-by-step states or process or a way, so it is going to execute step by step. As a compiler point of view, it will be step by step. How signals change over time or events. So we use times and events in our Verilog testbench and everywhere. So these times and events we can include in our procedural block, and they are used to model logic, generate stimulus, control, and simulation flow. So all over your logic and everything will be inside these procedural blocks. And let's see. So first is our initial, runs once at a simulation start. So initial block is mostly used in our testbench and initialization of some variable, and as its name suggests, its initial means first step, you can say, and only execute once because it is initial now. So initial is only at once, at that also at the first time. So at zero simulation it will execute, and opposite to that there is a final block. So final block runs once at simulation end. For example, if you have used $finish at 100 nanoseconds, so the $finish will execute, and just before that the final block will execute at the end of the simulation. So printing some summary or report, you can say, we use this block. And our mostly used block is always block and initial block. So always block is our logical, where we write logic, case statement, if else statement, everything which we use this always block. As you know that hardware is always running, so we need something to always run. So this always block is used for that because it is always running. So runs repeatedly on trigger or event, so we can control it with our trigger and event, and combinational and sequential circuit you can create with this. So let's move forward and see this step by step.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
So first is our initial block, and used for initialization, as I said earlier, stimulus or displaying output in testbench. So mostly we use initial block in our testbench because it is not synthesizable, because as you know hardware is running always, so always block is synthesizable, but initial block is not synthesizable. There is no hardware which only runs once time. Okay, so execute only once at time 0. So as I said earlier, at 0 simulation time, whenever the start of simulation, it will initialize or start or give some values, and you can use as you can see here is a code for a simple initial block. So a equal to 0, as we initialize this, and we can use delays and $finish statements in this initial block. So $finish is like you will write this statement and it should execute once. For example, if 100 nanoseconds you have written $finish, or here we can say 10 nanosecond or 10 units of time you have written $finish. So after 10 nanosecond there is no another $finish. So why we will write this in always block? So this is some statements we use for only initial block. We can write in that, but why should we write? That's the question. So non-synthesizable, as I said earlier, execute in sequence blocking style. So it because we have used our blocking statement. So for non-blocking it may change sometimes, but initial block is like initializing everything, so mostly it will go by sequence. Idle for testbench and stimulus, as you see in testbench we give some inputs, and we can use for forever block and for loop, so we can use inside this initial. So it is idle for testbench, and monitor display statements we can use here, and clock or reset generation also we can do there. So this is our first block. Second is our always block, which we will write logic for our all the logical blocks like combinational, sequential, and everything. We will go towards that in next slide. So firstly, it execute continuously during simulation whenever the sensitivity list is changes. So this inside this, whatever you have write is called sensitivity list, and whenever the sensitivity list changes, or whenever you are triggering statement, like here you can see in green, combination logic is write like a star, or you can give any variable name A or B. Star is used for writing all the variable. It will consider every input. Whenever the input changes, you can say your always block will trigger, means execution will start from beginning. So whatever this procedural code is there, it will execute. And in sequential, if you write passage or negate of clock, so whenever the clock is there and passage of clock will there. Okay, I will take one example for that. So yes, so for example, this is our clock, and whenever this process is coming, so we will include this. For example, this is clock, so we will write this signal name is clock, and this signal is coming inside this our always block, this always block. So whenever this passage is coming, it will execute. So this is the logic. So what happens if we write only always and not write anything at the rate? So this is the statement will execute, it will not give compilation error. Means if you don't use this part and only execute this and rest of the code, so what happens is your simulation will get hang, or you say it will having so much things to execute, it will get stuck somewhere, or you can say you cannot execute this much of simulation. It will continuously going on, it will not stop. And even in dollar finish also, for example, if it is going 1 nanosecond, 2 nanosecond, 3 nanosecond every triggering. But what happens in always block, in between 1 and 2 there is also a infinite number of points, so this will execute. So for example, if dollar finishes at 3 nanosecond, so it has so many points from 1 to 2, it get stuck there and it keep executing that same thing. So don't use always block without any triggering statement. System Verilog has some more concept in that, and they have include always com and always block, some varieties of always block. So we will see in when we will have our System Verilog course. So first, always block has two type of execution, as I said, is sequential and combination block. So for example, if multiplexer, or that is 2:1 multiplexer logic you are writing inside your code, so and I have already created simple videos for our normal circuit, so you can watch that rest of the code like module and everything. But for now, you can say the always block is the main logical block. So this is our conditional statement if and else, and you can execute this with the help of always block. Here it is used star, so whenever the select or A or B are changes, it will execute. And we are using this type of statement for combinational circuit, and for sequential circuit we are using passage of clock and passage of reset. So this is asynchronous because reset is coming without a synchronization of our clock. So you can write sequential circuit with the help of our always block. And here our flip-flop code is this. So whenever there is Q, it will get D value. So you can write this too, like sequential and combinational code with the help of always block. So let's move forward. And our final block, and finally we are reading this final block. So System Verilog feature, this is, and what this means is that there is no Verilog final block, but now all our Verilog is updated, so you can say there may be final block. So you can study this like a final block execute once at the end of simulation, as I said earlier, after all the blocks are finished. So whenever all the blocks are finished, like all the things code and simulation time is finished, it will execute. But before simulator shutdown, as I said earlier, like if there is 100 nanosecond dollar finish, you have written, so it will not stop at 99, but it will just before, like 99 and 100 is there, so just before 100 it will execute, you can say, means close to our 100 or on 100 only. And it is non-synthesizable, as you know, there can be no circuit like hardware for final block, so it is non-synthesizable. And printing final summary we have used, like in scoreboard you are printing a result, pass and fail value, we can use there. Checking simulation results, as I said now, scoreboard. And releasing our resources, so whatever you have to execute at final block are mostly these 2 points, so you can ignore this one. But releasing your resources, it is not important for now because we will see this in our System Verilog. So this is our simple syntax for final block: begin and you are just printing value of time, at what time the final block is executed. You can run this code. And let's see one summary for all of the blocks. So these are our main procedural blocks, and once at the start, once at the end final block, and repeatedly at events. Mostly used in our test bench. In initial and final blocks are non-synthesizable. It's here non-synthesizable. RTL design logic and report and cleanup. Cleanup is a phase in our UVM and system Verilog. Also there is a phase. So cleanup is like whenever you are printing a report or any result or scoreboard, so you can say you use our final block. And yes, common use is for stimulus, because we are using in test bench, so we are giving stimulus. Design logic, as you say seen earlier, like RTL design, so it's logic we are writing in all those blocks. And test bench summary, as like scoreboard and everything, the result will be printed in final block. And this too will have we are studying in next video, but for now it is immediate execution, it is scheduled update. And in next Verilog day 4 video I will tell you about blocking and non-blocking. So yeah, so blocking is used for combinational and non-blocking is for sequential. So why we are using this for sequential and combinational, we can see in next video. So thank you, and you can comment me for any Verilog and any related topics for VLSI industry. So thank you.
Please Lord, give me a sign, a sign.